Hi guys, welcome back. So in this video, let's understand what imbalanced datasets are and how do we tackle them. So let's say we have a dataset DN, and this is a two-class classification dataset, which means that there are only two classes, right? And let's say that there are 1000 data points in this dataset, out of which 460 are positive and 540 are negative, right? So the difference between the positive and negative classes is not very high, right? I mean, there are only 40, there's a difference of 40 to get them equal. So this dataset is considered as a balanced dataset, right? Now let's take another example where we have a dataset Dn, which has, let's say, 100 positive classes and 900 negative classes, right? Now, in this data set, you would see that the difference between positive and negative classes is very high. And a data set like this is actually very common in medical applications where you're trying to find the disease for disease in using a data set. You'd usually get a data set like this where you have a lot of data points where the disease wasn't found and a few data points where the disease was found. And if the difference is very big, it's called an imbalanced data set. Okay, and imbalanced data sets are very, very common in real life. So, knowing how to tackle imbalanced data sets is very important. Generally, the industry standard for considering a data set as imbalanced is 70/30. That means if you have 70% of if you have more than 70% of less, yeah, if you have more than 70% of the points in one class and less than uh, 30 in another class, it would be considered as an imbalanced data set. So over here, we can see that the difference is almost 90/10. So this is an imbalanced data set. This is the industry standard. That's usually what's followed in the industry. Okay. So now that we know what imbalanced data sets are, how do we overcome this problem when we are building a model? So the first way to overcome this is downsampling, right? What downsampling does is that we have a data set with 100 positive points and 900 negative points. So when we build the model, we don't take all the 1000 data points in our data set to build the model. What we do is we take another data set, dn dash, where we take 100 data points from the positive class and we take 100 data points from the negative class. Okay, this balances our data set. Now the ratio is 50/50. So our data set is balanced. And yeah, this is what downsampling is. But there's a problem with this. Not one, there are a few problems with this. The first one is that, if you have so much data, you would obviously want to feed your model all the data, right? Because generally machine learning models perform very well when they have a large data set to learn from. So a smaller data set may not make the machine learning model, may not make the ML model generalize well. Okay. So we obviously want more data, as much data as possible, so that the model learns better and performs better on unseen data. Right? This is negative. The second problem with this, and the most important one in industry, is that you know in real life, acquiring data is very, very expensive. It's time consuming, it's arduous, it costs a lot of money. So you can't just throw away so much data and just say that, okay, I'll downsample my data and use and build a model on that. So because acquiring data is expensive, downsampling is usually not a very good choice. Downsampling is not a good choice. to deal with imbalanced data sets. So how do we overcome this? Well, there's a second technique. As you might have guessed, like we have downsampling, we also have something called upsampling. Okay. So what upsampling does is, let's again take the same example. I have 100 positive points and I have 900 negative points. So I create a data set dn dash where I have 900 negative points, but my positive points, I just add the same points over and over again. So if I have 100 points, I just add the same point over and over again to make it 900, and hence a balanced data set. Okay, so this becomes balanced. What that means is that, I'll just change the color code and give you an example. Let's say I have uh, these are all my negative points, right? And these are all my positive points. Now you can see that the negative points are much larger than positive points. So what upsampling does is that I will just add more points. Whatever is the class that is less in number, I'll just add those points over and over again until both the classes balance themselves out. So I'll just add the same point again over here, again and again. Same for the other points as well. So earlier there was just one point at the same in the same dimensional space, but now there are 3 or 4 points in the same dimensional space, as many as you need to balance the classes out. Okay, this is on top of each other, the same dimensional space, the same values. That's called upsampling. So now another point is, in case you don't want to upsample on top of, usually upsampling is done on top of the same points. If you have the positive class, which is less in number, you take the points and you just put it on top of each other with the same values, same features, same everything. In case you don't want to do that, what you can do is third. It's not the third point, but it's basically a subsample of this. You just change the data structure. Okay. What that means is that I have the positive points here. What I'll do is, inside, close to these points, I'll add more new points. I'm basically making my new data points, and I'm adding them here over and over again. How you would want to do is, you would set an upper bound and you would set a lower bound. You would try to find the central point of this data set of all the positive points, and then you would set new points inside that range. So this is called, you're basically changing the structure of the data set. You're adding more points. So this is another technique to overcome that. It's actually called creating synthetic points. Okay. This is called creating synthetic points. And the third and another important technique is weighted data. Okay, what is weighted data is that, if I have the data set dn where I have 100 positive points and 900 negative points, each of these negative points would have a weight of 1. And each of these positive points would have a weight of 9. So even if I take some classification technique like KNN, I would give the positive point a weight of 9 and a negative point a weight of 1. This is similar to upsampling on top of each other, upsampling data points on top of one another. So that is weighted data. I just give a data point a weight so that it sort of balances out when you're trying to make a classifier or a regressor, anything. So these are some of the techniques to deal with imbalanced data. By the way, this upsampling technique it's usually called SMOTE in real life. You have something called SMOTE, which is the upsampling technique. If you just Google search it, you will get it. I think it's also available in sklearn, I'm not sure, but in real life it's called SMOTE.